Hello everyone. So let us start the next type of problem. That is again same by Kanye's method. Analyze the continuous beam by Kanye's method, and EI is constant throughout. In case if this sentence is not given that EI is constant throughout, or in case if they have not mentioned anything in this figure, then it is understood that this EI is constant throughout. Okay. All right. So first, as usual, first you have to find the fixed end moments, then rotation factor, and then rotation distribution. Okay. Moment distribution here, that is, and then the final moment calculation. Okay. So the different thing about this problem is the previous problem, all the ends were fixed. Okay. So end A and end D were fixed. Here, end A is fixed, B and C are the roller and intermediate support, and D is a roller support. Okay, it has a roller support, that is, D is a simply support. Okay, so first find out the fixed end moments. To find out the fixed end moments, calculate all. See here, A and AB and CD, they have the point load, that is concentric point load, and in BC there is a UDL. Okay, so first MFAB is minus WL by 8, so it is plus 25. MFBA is plus WL by 8. Okay, next MFBC is a UDL, so minus WL square by 12, it's minus 26.67, and MFCB is plus 26.67. Likewise, MFCD, again there is a point load exactly at the center, so it is the minus WL by 8, and MFDC is plus WL by 8. Okay. Next thing is find the rotation factor. Again, the rotation factor you can find at joint B and C. So joint B, it is BA, BC. Joint C, it is CB, CD. Okay. So first, joint B. Joint B is BA. So you can see here. So BA and BC. So BA is the 4 EI by L. Again, joint C is treated like a fixed support. So it is again 4 EI by L. So both are 4 EI by L. Next, similarly, joint C. So CB, again B is the intermediate support. So it will be treated like a fixed support. So it is 4 EI by L. But from C to D, again D is the end support. Because it is the end support, it will be treated like a simply support, and this simply support has a formula 3EI by L. So 3EI by L. Again, here nowhere they have mentioned the EI value, so it is understood that EI is constant throughout. Okay, so once you solve this, again find out. So it is K summation K. So rotation factor is equal to minus 1 by 2 or minus 0.5 K by summation K. So don't forget to write this minus. You have to always K by summation K into minus 0.5. You have to multiply this. Okay, once you get these values, okay, so come back to this point. So once you get these values, so it is now rotation contribution. Now you have to calculate the rotation contribution. Now again, if you see this figure, D is a simply support. So we know that wherever there is a simply support, we have to balance those moments. Okay, because this is similar. Same case in case of moment distribution also. So wherever there was simply support, okay, or roller support, those moments should be removed, and that particular joint should be made, the moment at that particular joint should be equal to 0. Same thing should be done here also. So we have to modify the CD span, because D is the joint wherein there is a simply support. So you have to modify the moments in this joint. Now, to modify the moments in this joint, we have the formula, that is MFCD. Okay, MFCD is to be modified because that is the last span with the simply support. So MFCD is equal to, so whatever moments is occurring here, that is in the fixed end moment, okay, that moment should be transferred to joint C. Okay, once again, whatever moments is occurring at joint D, okay, that moment should be removed, made 0, and whatever moment, fixed end moments is occurring at this portion, that should be transferred to joint C. Okay, so And the formula goes like this. So MFCD, so this is modified MFCD. So MFCD is equal to original MFCD minus half of that. Okay, so minus 0.5 unbalanced moment at D. So unbalanced moment at D is, see here, say MFCD is minus 25 minus 0.5 means half of moment at D. So moment, so what we're doing here is add this moment, that is minus 25, then minus half of this moment. So this moment is, we've already calculated here, that is plus 25. Okay, so that's why it is minus 25 minus 0.5 times the unbalanced moment at D, exactly at point D. Okay, so now why we need to do this is because we know that moment at the simply support is always 0. So in order to make it 0, so whatever moment is existing at joint B, half of that should be transferred to joint C. Okay, so this is like the carryover moments. Okay, half of this gets carried over. So now the final moment, original final moment, fixed end moments at C is MFCD is equal to minus 25 and minus 12.5. So it is minus 37.5. Now this is the value you should take. So MFCD is minus 37.5, whereas MFDC is equal to 0. Now why it is 0? Because the moment, whatever moment which existed there, we have removed that and made it 0, and that moment is transferred to this portion. So that is minus 37.5. So these are the final moments. Now we have to write it in the rotation contributions. Okay, now next is you have to again draw the moment as usually. You have to draw this figure. So again, B and C, draw two bigger squares. Okay, joint D, show it as a simply support only. Okay, yeah, I can show it as a roller support, hinge support, or simply support, which no problem. Either of the one you have to show. Okay, then what you have to do is, as usual, fixed end moments. So we have already calculated the fixed end moments here, this portion. So it is now minus 25 plus 25. Then BC is minus 26 plus 26. Okay, now this is important. So whatever is existing at C, that moment, so this is your modified moments you have to take. So modified moment here is MFCD is equal to, okay, so it's minus 37.5, and MFDC is equal to 0. So the main important thing here is you have to make joint D 0. Now to make joint D 0, again half of this should be transferred to this portion, and that is the modified moments. You have to write it here. So the end product is this moment at this portion should be 0. Okay, then as usual, go on finding out the same repetitive, start doing the iterations one by one. Okay, you have already calculated the rotation factors, so mark here. Okay, in BA minus 2.5, BC also minus 2.5, then CB minus 2.86. So you have to CB, you have to write it in this portion, CD you have to write it in this portion. Okay, next is add this. So it is 25 minus 26.67. So it is minus 1.67. So you write it here. Similarly, 26.67. So at joint C, it is connecting these both. So it is 26.67 minus 37.5. So it is 10 minus 10.83. So these are the final values which we'll be using for calculations. Now take down this. So again, the iterations goes like this, one by one. So first thing is, if you want to find MBA, okay, so MBA is equal to minus 1.67. Okay, so that is the moment at B, moment at joint B. So it is minus 1.67 plus, now far end moment, we have, okay, so the final moments are, so minus 1.67. Okay, next far end moment, we have not yet calculated all of this. This is the first thing we are calculating. So minus 1.67 plus 0. There are no moments in the far end. So plus 0. Then into this rotation factor. So it is minus 2.5 minus 0.25. So it is 0.417. Now, similarly at this portion also. So minus 1.67. Again, far end, no moment, into minus 0.25. Okay, write it here. Next, come to this portion. Now, these are the values we've already calculated. Okay, now come to this joint. So it is minus 10.83. Next, minus 10.83. So that is the moment at joint C. Next, far end moment is this. So far end moment is plus 0.417. Okay, into minus 0.286 is 3.097. Okay, next, similarly in this portion, so it is minus 10.83. Again, far end moment with respect to C is B, this portion. Okay, so it is 0.417 into minus 0.214. The answer should be written in this portion. Okay, similarly calculate the next iteration, and most important thing here is whenever you are calculating this, always draw this dotted line here. Means it becomes very prominent that whatever you write to the left side becomes the moment because of BA, moment right side of this moment because of BC, again left side of C, moment because of CB, and right side of this is moment because of CD. Okay, that's the first iteration. Similarly, calculate the second iteration. The second iteration goes like this only. So it is minus 1.67 at joint B, minus 1.67. Next far end moment with respect to B is this, which you have already calculated here in the first step. So it is minus 1.67 plus 3.097 into minus 0.25. Okay, write it here. Similarly, next here also it is 0.25, so same answer you'll get. Next, come to joint C. So joint C, with respect to joint C, again this is the far end moment, so it is minus 10.83. Far end, in the second step we have calculated, far end is minus 0.356, okay, into minus 0.286. Write the answer here. Similarly, minus 10.83, again minus 0.356, okay, 0.356 into minus 0.214. Write it here. So same iteration carry out here. Minus 1.67, again far end is plus 3.199 into minus 0.25. Same thing here, both are same rotation factors. Next, minus 10.83, again far end is minus 0.382 into minus 0.286, again same answer, into minus 0.214. Okay, so again calculate the same thing. So at the last fourth iteration you need to stop this here. Okay, so because the difference between the third step and the fourth step is not much. So you can see here it is 382, this is 384. Same thing here, then it is 206, 207, 399, here it is same only. So this is the point where you need to stop. So you should carry out this iterations until the difference between the previous step is not much. So once you get these values, now these are the values you have to use to calculate the final end moments. Okay, so final moment calculation is first joint A, B, C and D. Okay, then member AB, BA, BC, CB, CD, DC. Okay, so we know that the member, when you're taking this fixed end moments, so we've already made this 0, and whatever moment existed here, that we have transferred to this portion. Okay, so minus 25 plus 25, minus 26 plus 26, minus 37. So check is make this point as 0. Okay, after that near end contribution, far end contribution, and final moments. Okay, so near end is nothing but, so with respect to B, near end is BA and BC. Again with respect to C, it is CB, CD, near end. So always the near end contributions are twice. So when they are twice, so BA, so BA is minus 2 into minus 0.384. So write it here. Again BC is also same, 2 times into minus 0.384. Next CB, okay, CB here, so 2 into 3.207, 2 into 3.2.399. So write it here. So always the near end contributions are twice, so multiply it with 2. Okay, so rest becomes 0. Only BA, BC, CB, CD becomes twice, and rest all is 0. Next, the far end moments, so whatever is here, okay, that moment get transferred to far end. So with respect to B, the far end is AB, so only that moment gets transferred, so it is minus 0.384. Okay, And next, this moment get transferred here, this moment get transferred here. With respect to B, okay, C is the far end. So whatever moment exists here, that will get transferred to this portion. Next, with respect to C, okay, with respect to C, B is the far end. So it is 3.207. It gets transferred here. Rest all becomes 0. Okay, so only these things you have to know. Far end contribution is whatever moment exists here, that gets transferred here. Similar, this moment gets transferred here. It's like a crisscross. It gets transferred here. And finally, we know that this should be 0 only because it's a simply support. Once you get the near end and far end contribution, next is the final moments. So the final moments is add all of these. Okay, B C C D, and the check here is whatever moments exist in B and BC, they should be equal and opposite. So it is 24.2, so it's plus, this is minus. Here also it is plus and it is minus. Okay, so this is the check. So these are the final moments. Okay, once you get the final moments, you can actually also draw the bending moment diagram, which we have already done before. Okay, you can just draw the same bending moment diagram for first is the free bending moment, and next is the including the final moments, uh, draw the bending moment diagram. All right. Okay. So that's all for today. Thank you.